Hello everybody and welcome to the Math Skills lesson on area and volume. Now the reason for this lesson, it is obviously at A-level extremely important that you can convert back and forth between any area or any volume unit that you might have and the SI base unit. Now to have a look at this, we're going to start first with one dimension. And in other words, when we're talking in one dimension, we're talking about measuring length of some forms. It may be distance, may be displacement, it could just be the side of a shape or something like that, but we're going to be measuring length in one dimension. Now, we've got a few different units that we're going to use. I'm just going to cover a couple of the major ones. Obviously, centimetres we see quite a lot. Millimetres I would normally use instead of centimetres, to be brutally honest. And of course, we've got kilometres as well. But of course, when it comes to length, we know that the base unit for length is the metre. The centi, the milli and the kilo bit are just SI prefixes. If we wanted to convert then back into the base unit, so into metres for all three of them, well, this we should know by now. To go from centimetres to metres, we would divide by 100. So in other words, if we had 237 centimetres, that would be 2.37 metres. We've divided by 100. For millimetres, we would divide by 1,000, and then for kilometres, we would multiply by 1,000. Now, in order to understand the next step and to understand how we're going to calculate area, what we're going to do is we're going to imagine that we're taking a line and that line is 1 metre long. And what we're going to do is we're going to divide that into centimetres. Okay, so these are going to be centimetres, and obviously we know that as we get up to the other end, we're going to have a total of 100 centimetres. In other words, we divide that line into 100 parts. Now, if we were to do exactly the same in the second dimension, so we would have 1 metre long, and we'll divide this up into centimetres. Okay, and again we know there are going to be 100 centimetres by the time we get down to the bottom, and in one dimension that's absolutely fine. What we're left with though, from an area point of view, is if we measure one of these little squares here that I'm just going to colour in. I'll colour this in blue. Okay, that little box there is 1 centimetre on one side and 1 centimetre on the other side. Okay, so that's zooming in on our little box. Now we know that to calculate area is just 1 centimetre multiplied by 1 centimetre, which is 1 centimetre squared. Now of course, if we were then to build this up, so there's another centimetre squared and another one and another one, and obviously going in both dimensions. Okay, and obviously I'm not going to draw them all in because it will take me all day to do that, but we can see that what we're going to end up with is a lot, obviously, of these little 1 centimetre squares. And of course, in order to convert centimetres squared into metres squared, what we need to do is we need to count how many of these little 1 centimetre squares there would be if we scaled it all the way up to a metre. Well, of course, if we start counting them, there's going to be 100 of them in that direction, and there's going to be 100 of them in that direction. And therefore, to count the total, we've just got a grid which is 100 by 100. Now, of course, you can have a look at a similar illustrative example of a chessboard, and whether or not you're familiar with chess makes no difference at all. We're just looking at the board, and we can see that in each direction we've got 8 squares. Now, of course, if you really want to, you could pause the video and you could count up the number of squares if you've really got so much time on your hands. But hopefully we can see that we've got 8 rows and each row contains 8 squares. Of course, if you want to look at it the other way, you've got 8 columns and each column contains 8 squares. So therefore, the total number of squares is 64. But of course 64, very simply, is 8 squared. In other words, when we've got something that's the same on both sides, we just take the number of scale divisions in one dimension and we raise it to the power of the number of dimensions. So therefore, with our square going from centimetres to metres in each dimension before, how do we do it? Well, we just say that there are 100 centimetres in a metre, so we have 100 scale divisions, and we raise it to the power of the number of dimensions. So we end up with 100 squared. Now, of course, on your calculator, if you were to do 100 squared, you would end up with 10,000. But to be honest, that makes absolutely no difference to us. We don't need to remember that it's 10,000. All we need to do is remember that it's 100 squared. So bringing that back onto here then, if we look at 2 dimensions, okay, in other words, we're now looking at an area. If we go from centimetres squared into metres squared, we're going to divide by 100 squared. Same with millimetres to metres squared in both cases. We're going to divide by 1,000 squared, and for kilometres squared into metres squared, we're going to multiply by 1,000 squared. Now, of course, when it comes to 3 dimensions, we're just taking this one step further, and the same thinking that we've just looked at applies. So obviously in 3 dimensions we're now looking at volume, so centimetres cubed to metres cubed, we would divide by 100 cubed, millimetres cubed to metres cubed, we would divide by 1,000 cubed, and kilometres cubed into metres cubed, we would multiply by 1,000 cubed. Now, while understanding how to do area and volume conversions, which you've already got something in squared or cubed, is all well and good, by far the easiest way of doing it, if you have the opportunity, is to do your conversions first before you do any calculations. So let's imagine that we have a cuboid shape. Let's say that it's 10 centimetres by 15 centimetres by 20 centimetres, and obviously we can see that this diagram is not to scale. And let's say that we want to know what is the volume in metres cubed, because of course we're trying to deal with the base unit here. We're dealing with metres cubed, we might be trying to measure density or something like that. Well, of course there are 2 methods. What we could do And in my opinion, the more difficult method is to calculate the volume in centimetres cubed first. So 10 times 15 times 20, which is equal to 3,000 centimetres cubed. And then in order to convert that into metres cubed, so remember that centimetres cubed to metres cubed, we divide by 100 cubed. So when we divide that one by 100 cubed, what we end up with is 0.003 metres cubed. Now, of course, the simpler method would be to do all of your conversions into metres first. In other words, very simply, 10 centimetres is 0.1, 15 centimetres is 0.15, and 20 centimetres is 0.2. And of course, if you plug that into your calculator, you end up with exactly the same answer, 0.003 metres cubed. Now, in my opinion, I think if you ask a lot of other physics and maths teachers what's easier, hopefully they'll all agree with me that it's far, far easier to do those conversions first. Because, to be honest, especially at A-level, you should by now be able to convert very quickly in your head, without really thinking of it, 10 centimetres into metres. And at that point, it makes the calculation easier. And to be honest, it makes you less prone to making mistakes in doing any of these calculations in the first place. So here is your question for this video. Calculate the following in base units. The area of a circle of diameter 17 millimetres, and then B, the volume and the surface area of a sphere of radius 36 centimetres. So at this point, pause the video, go and have a go at those questions, and then come back when you think you've got an answer. Now for A, the first thing that is the attempt to catch you out is giving you a diameter of 17 millimetres. What you could do, I suppose, at first is you could then divide it by 2 and say that your radius is 8.5 millimetres, but I will show you in a moment a slightly different way, a slightly more elegant way of calculating area from diameter. So of course we've got radius 8.5 millimetres. Now, as we said before, immediately I would convert that into 0.0085 metres to plug it into my calculator. Now for area, we know that we've got pi r squared, so it's pi times 0.0085 squared. And when we get the answer to that, we end up with 2.27 times 10 to the minus 4 metres squared. Now you'll notice at that point that I haven't left it in terms of pi. If we're doing intermediate calculations, it's not a problem to use pi, but of course for a final answer we're always going to round. Now of course if you didn't do the conversion into metres first, then your calculation becomes pi times 8.5 squared, and that gives you an answer of 227 millimetres squared. But then of course you would need to divide by 1,000 squared in order to convert to metres squared, and you end up with exactly the same answer, 2.27 times 10 to the minus 4 metres squared. Now of course instead of using pi r squared, there is a slightly easier way of dealing with diameter. So remember that radius is just diameter over 2. So therefore when we substitute it in, we end up with pi times diameter over 2 squared, which when we multiply that out, we end up with pi d squared over 4. And you might want to do that as a little exercise for yourself to make sure that you still get exactly the same answer. Now for B then, okay, firstly we'll do the volume. So the volume of a sphere is 4/3 pi r cubed. So we're going to do 4/3 times pi times the radius, which I'm immediately going to convert into 0.36 of a metre. And of course that is cubed, not squared. And what we're left with there is we end up with an answer of 0.195 if we're going to go to 3 sig figs metres cubed. Now for the surface area of a sphere, if you don't know it, it is actually on the data sheet and is 4 pi r squared. So that gives us 4 times pi times 0.36 squared, and that gives us an area of 1.63 metres squared. Now, of course, if you decided not to do your conversions first, please make sure and check that you've done your conversions correctly and you do get those answers. So to summarise then, if we have to do area and volume conversions, remember if we just take the linear version, so let's just take centimetres as an example. If we go centimetres to metres, we know that we would divide by 100. Whenever we go up to area, we square the unit and therefore we square the scale factor, and to volume we cube the units and therefore we cube the scale factors as well, and that will work for any conversion. So whether it's millimeters, whether even you go down to nanometers or something ridiculous like that, and want to convert into nanometers cubed into meters cubed, you can just apply that principle. But of course, just remember that it's far easier to do your conversions first rather than trying to do your conversions afterwards. So that's it for this video. I hope you've enjoyed that, and I'll see you in another video.